So first of all, I will introduce myself. So thanks for to be here. My name is Massimo Brignoli. As even I'm Italian, so I can speak for hours. So 45 minutes is really not enough, just to say hi. And today I wanted to talk about what we do with the Kubernetes. Okay, there are two parts, and one is related to the concept of observability and monitoring. So first question, as Ivan has done. So who knows already Elastic? Who is using it in production? Very good. So for what? Search, monitoring, or logs? So you know already everything. So what to do here? So why Kubernetes then? So I will do a brief introduction also to what we do in terms of monitoring. So everybody will be on the same page. So why Kubernetes? Because Kubernetes, because it's coming to all the enterprises. So every time I go to an enterprise company, they are or planning to use or they are already using Kubernetes inside one of the services that can be the Google one or Pivotal or OpenShift. Okay. Someone is using Kubernetes in production here? Or planning to use it or testing or something like that. The problem with Kubernetes to monitor all the Kubernetes is that complicated, no? So it has a lot of of elements, very variable also. That is the concept of the product, and so it's not easy not to have a complete view of what is going on. And also, so we have a different layer, no? Because we have the cluster, the node, the container, the application, so different layer with a lot of elements that must be monitored and controlled. So to cross all the communication between all these elements is not easy. So the concept is the observability. Observability is a term that is coming from Twitter. The first time it was used, it was in 2013, so 6 years ago. And we are still talking to them about observability. And so this guy was a visionary, and not Peter. And so the observability concept is that so you need to observe the system with a lot of different angles. And the concept that we are suggesting is to use the three pillars. So the logging, that is the most common one, is only one of the pillars of the observability. Then the matrix, so number, KPI, and the tracing, so APM, so application performance monitoring. So what we wanted to do is to propose one single product that will be here. Okay, that is Elastic, that is able to do all the three things. Of course, it's not easy, so I have a lot of slides, but because I wanted to give a complete presentation with a lot of stuff, of course, we will not discuss all the slides because otherwise it will take 2 days. And so Elasticsearch is very well known not to be used for logs. So this is where I started from. And why? Because of course it's due to the full text search capabilities, not to analyze the text and the logs. Logs that can be logs of standard logs of machine, but it can be also custom logs of application when you have to do searches. So what in the past, what we tried to simplify life of everybody, developing modules. So we have a lot of modules for specific log files. So for Apache, for Nginx, for whatever. So 120 different kind of logs. And every time you pass the logs, we can create already all the dashboard, all the machine learning jobs, and all the what you can need inside the stack. For who doesn't know well Elastic stack, so Elastic is composed by 3 layers, so ingestion, store, and visualization. Okay, and so we try to give a complete solution, and with the 4 different components of the stack that are in ingestion, there are Logstash, that is the ETL, to transform the data, the bits that are the agents that are collecting information everywhere, and Elasticsearch, of course, that is storing and querying the data, and Kibana for the visualization. So this is the stack information. So this is the typical dashboard that you can see in a Kibana, generated automatically based on the log file. So we have a lot of this logging module that can log more or less everything that you have in your machine, from infrastructure, database, application, or whatever. Okay, producing this kind of the dashboard. Then, and it is fine. So we have a full text search capability to analyze log is perfect. Then the problem started when we decided then to store also metrics, because full text search is using an inverted index, that is this one. Okay, an inverted index is a list of words that you have in the strings with their frequency and where, in which document they are appearing. This is how it's done in inverted index. So when you have a structure like this, how then you can use it to store metrics? Metrics are numbers, are KPI, no? So you need to transform a little bit the storage. And this is what we have done in the past, and this is probably the most unknown part of Elastic. So the original inverted index was using Lucene and was designed in 2010. Okay, so 9 years ago. In 2012, so then what we decided to do to store structured information, we developed a columnar storage inside the Lucene implementation. So Lucene today is able to store two kinds of information, so full text information and the structured information in the columnar storage. The advantage of columnar storage, of course, you have listened this morning with Maria Louise given the presentation about this, and is giving a lot of advantages, also in terms of aggregation, but also in terms that you don't need to create specific index on it. So you store in the columnar storage and then you search without doing any other activity. So the point is that this is not enough. So to store structured information is the first step. Then in 2014 arrived the aggregation framework, so the language and all the algorithm to do aggregations inside the store, no? And this was 5 years ago. And so this transformed the role of Elasticsearch in just a full text search in an analytic store. Then we have done a lot of other optimization, arrived at what are called BKD trees that are very useful in storing numbers and are used today to do some faster analytics and especially for geographic searches. So all the geo information are translated in GeoHash and stored in the BKD trees for very fast. It's dead. My laptop is completely dead.
Yeah.
It's really dead.
You have it on...
No? Doesn't react.
Spegni e riaccendi, sono anni che c'è da soddisfazione.
No, non si...
Non si spegne neanche?
No, è spento proprio. No? Sorry, but you see that it's not receiving the power. Ah, no, perché sono attaccato. Ah, adesso guarda qua. Ah, perché c'è qua così. Però dammi questo qua, sì. Sorry, sì, un po' più grosso. Ah, ok. Perché sai che non sono sicuro che questo alimentatore funzioni benissimo. Oh, no, use the other one.
Sorry, that.
No, guarda. Ok, ok, va bene, adesso riparte se vado avanti. Sorry, so my laptop is dead. While we are waiting that it is starting, I will continue on without slide, no problem. And so we're saying, so we implemented these BKD trees that are very useful. For example, imagine in Uber, no? Uber is using Elasticsearch to find the nearest Uber driver, no? On the map based on your location. To do that, of course, is not querying and calculating the distance of all the Uber drivers in the world, not to understand who is the closest one. That's not very efficient. So what is done, of course, is simplifying the search and reducing the location based on the duration. And then that is ordering, calculating the distance. So, and is using this, the BKD trees. Very important information in structured information. So, based on this, so we transformed completely the role of the storage, so not only inverted index, not only full text, but added the full numbers, matrix capabilities. In this way, we were able to store time series, to aggregate them, and so on. Another point was last year we released the roll-up indexes, means that you can create jobs that are aggregating real time with the different matrix, different granularity, the data that are coming in streaming into the main index, no? So the time series. So for example, you have data coming in and you can decide to aggregate information by hour, by day, by months, by week, by month, and so on to have a very longer retention period, no? Compared to the raw data. So with all this, then we will be able to use metrics. And we developed these agents are called bits, so there is a family of agents. There are some of them that are dedicated to collect matrix information from all the infrastructure that is at server level, host level, so in terms of CPU, RAM, free storage, and so on, but also inside the application, or inside your application server, or inside Kubernetes, or inside the database. So if you want to collect information from MySQL, DB, and so on, we don't have for Neo4j. And this is the matrix part, okay? Then the evolution was, last year, we acquired a company that was doing an APM product. Do you know what is an APM? No, application performance monitoring. Nowadays, everybody call it tracing. Okay, oh, my laptop is alive again. Okay. So I have a virtual machine running, let's stop it. Okay. So what's here? So there are these families of products that are collecting a lot of information, no? So from the operating system, goes inside the Docker, the Kubernetes, and so on. So these family of products are bringing a lot of information. You can see we have matrix bits for a lot of different databases, queue, application, HA proxy, and whatever. Then we have added, I was forgetting this, also the uptime. Uptime is a bit, it's called a heartbeat, that is doing a ping, that is doing HTTP calls or TCP connection, telnet essentially. That is just to see if a system is alive and is responding. And then it's building all the dashboard on top of it. We have also one is called the function bit, that is a lambda function that is collecting all the information from CloudWatch to collect the metrics on Amazon. So APM. So the goal of APM then is different. So it's going inside the application. So to check why an application is slow or is giving an error. The two things. To do that, so we acquired a company that has developed an APM server. We opened the code, so we released everything on as open source. And then we are developing a lot of agents that can be put on the web server, supporting multiple languages, so Python, Java, now we are developing also .NET and so on, but also some agents that can be put on the browser, so these are JavaScript agents. Then in this way you can see how the application is seen by the end user, okay, on the browser. To do that, of course, the agent is collecting a lot of different information, what is happening inside the application, to arrive down to the queries, to the database. So it's also intersecting the JDBC queries. So this, you don't see this, but so for example, the selector, you can see the statement here and also where is appearing your code. This representation is showing you where your application is spending time, of course, no? This waterfall representation. With, of course, all the history of all the calls, what is the average response time, the peaks, and so on. All this information are written, of course, in an index inside the Elasticsearch. Means then that you can build alerts, you can build machine learning jobs, you can build all the intelligence that you need to understand anomalies and forecasting, all this kind of activity. What is complicated in microservices, so in Kubernetes, is the distributed tracing. Because if you develop a microservices approach, probably a service will call another service, that we call another service. So the calls can be cross services. So it's not a flow like this, waterfall, but it is very distributed, is more complicated. So to do that, so we calculate the trace ID every time the main service we receive a call. We calculate the trace ID, and then we will inject the trace ID inside the HTTP calls to other services. So every time a service is called another service, we will put the trace ID in the header of the HTTP. So the goal is to do something like this. And then we will look for the trace ID. So in this way we are able to visualize what is happening across services. So in this way we can understand in which service you are spending time. So which service can be a bottleneck. Okay, this is the base, because without this, will be impossible then to monitor the Kubernetes. Then of course there is also a user interface. This is how we collected the information, and the user interface that is showing you, of course, the average response time, all the services, the impact. The impact means that is the sum of the numbers of calls and the average response time. No? And so request per minute, and then you can go down on each service to understand what is happening inside and all the traces. The advantage of having all this information, so logs, metrics, and APM inside the same system, is that you can do correlations. Correlation is very important in understanding what is going on, to understand what is the root cause of the problem. That is the most difficult activity when you are monitoring the system. Because you can see that the application is low in that point, but you don't know why. So if from here, then you can link directly and you can see the logs, or you can see the metrics at the server at that time. So the CPU, the memory used, or other information of the database. So if you see that the selector was low, why? So you can visualize immediately the metrics in that specific point. Or you can see the logs of that specific moment. So having all the information all together are simplifying this. To do that, we developed also a schema that is called the Elastic Common Schema, ECS. The Elastic Common Schema means that we defined a superset of information that is comprehensive of all the information from logs, metrics, and APM. So all the elements of the Elastic Stack, so the bits, log stash, whatever, are all writing into this schema. Since all the information, also they will be written in different indexes, but all the information will have the same schema. So it means that it's very easy then to do query cross-index for correlation, to correlate all the information. Okay, this schema can be extended, of course, with your own stuff, and is published on GitHub. So it's an open source project. So everybody can contribute, can give feedback. So if you want to add something, you are very welcome. So coming down to Kubernetes. So to Kubernetes, we need to add a lot of other information in the common schema that we have seen before, because we need to write information about the cloud metadata, the Docker metadata, no? And the Kubernetes metadata. So we are adding a lot of information. So we have specific bits, specific modules for bits that are understanding and taking all the information from Kubernetes. How we deploy it? At a different level, because we have daemon sets, 5-bit and 3-bit, that are collecting information at the node level and then at the container level, inside the container. The important thing is that we have the logging part. So this is how it's working. So of course it's logging check all the log of the pods. I will skip this part. So 5-bit, of course, is doing the log collection. This is the point, is the auto discovery. That is the most difficult thing to do. So Kubernetes, since is how it's designed, is of course to start stop containers continuously. So it's impossible to think that you must change a configuration file, no, adding the new containers. Must be done automatically by the system. So the auto discovery will check, is checking all the log files, and intercept when it started the new container, or it stopped the container, or destroyed the container, and then it will start automatically the monitoring of the new container. Okay, this is the fundamental part, because without this, a lot of manual work, and of course will be completely useless. The modules of 5-bit are a lot. I told you there are more than 120 different log files. These are some of the main modules. You can see there are system modules, but also a lot of database modules, Q, Kafka, and whatever. The same with the matrix, no? That is collecting all the metrics at a different level. So at pods level and so on, and then we will put everything in a user interface that I wanted to show you. That is this one. I can show you. Connect to the phone. 7% is this one. So if you go to, there is a website called the demo.elastic.co. Okay, it's a public website. Here you can find all the possible, the demo of all the possible features of Elastic. So every time we release something, we will create also a demo there. So you can use it to play and to see what is going on. Okay, it's coming. Sorry, not the mobile connection is not so fast. So this this interface is designed to show hundreds, thousands, tens of thousands of different containers. Because when you have a very large infrastructure, you can have a lot of containers, and then it's becoming difficult to show them in a nice way. And this is how we do it. So there is, you can decide to represent the host, the Kubernetes, or the Docker level, no? So the pods or at the container level, and you can decide the metric that you want to visualize and how to group them. For example, here I grouped them by host, but you can use also multiple criteria. This is still loading. The color is showing you what is happening with that metric. No, just go. Then it's fine. Then it's going to yellow and to orange and red. So you can understand immediately which container can have some problem. And clicking on the container, you can see the APM information or the logs information or the matrix information in that moment on that container. This is very important, and this is why we talk about observability, because it is the comprehensive of the three elements inside one single storage. This is the concept. I wanted to show you live. Okay, so it's arrived. So if you look, so these are some of the demo. There is infrastructure. Okay, let's go on. Then we will talk about it later. Okay. So also the metric, of course, has the auto discovery as a logs. Very important. Matrix has a lot of different modules. Here are some of them. And then the tracing that we have already seen. Okay. I wanted only to show. Okay, this one. So this is the interface. So for example, these are all the container. I can just decide to show the host, Kubernetes level, Docker level, CPU usage. I can group by host, or I can group by any custom field that you want, and you can do, of course, multi-level grouping, by, I don't know, availability zone, then you group inside, you group by host, blah blah blah. Okay. All this information then are written inside an index. So for example, if I do here, I can show view matrix, and you can visualize immediately all the matrix of that container inside the host and so on. These are the most common matrix, just to give you a quick overview, if there is something wrong. Since all the information that's written in an index, you can do alerting, of course, based on thresholds, or you can execute machine learning jobs. Machine learning jobs is non-supervisioned algorithm for anomaly detection. There's two algorithms. One is for anomaly detection and one for forecasting. So the machine learning is trying to understand what is the pattern of that metric or multiple metrics, because you can have one metric and all the influencer of that metric, and understand what is the pattern, and then every time you have a new data coming, is associating, is calculating an anomaly score from 0 to 100. And then you can create alerts on the, of course, on the anomaly score. So you can say, if the anomaly score is more than, 50, 60, then set an alert. But in this way, you have an automatic system that is learning on the path, and is not only based on threshold. The threshold is old world, because you can have a system that has changed completely the behavior, also if it's between the threshold that you have defined, but has changed completely the behavior, and you will never notice it. Okay, so this is why it's very important to understand what is the normal pattern of every KPI that we store inside the system. Okay, and this is the first part. So how to monitor Kubernetes, but it's not only that. So in last month, what's happened is that we released also components to deploy Elastic or Elasticsearch on Kubernetes. That was the missing part. And I will show you how it's done this part. Is this. So there are, on Kubernetes, there are 3 ways to run application. One is using manifest or Helm charts, and these are based on just configuration and can deploy the system. So, of course, teams, DevOps, they love it because it can manage a very complex infrastructure. It's very easy to share, but they do only deployments. That's it. So they don't have any intelligence on top of it. So this is why the third system to run application on Kubernetes is to use an operator. The operator is not only the deployment, but is adding all the intelligence to create a cluster, to upgrade the cluster, and so on, to scale and to scale the cluster. A lot of companies are going in this direction. So in the last months, I think that you have seen a lot of announcements about this. MongoDB also has done it. MariaDB has it also. And so this is the right direction to go. So is the operator. The operator then is doing a lot of stuff. So you can manage a multiple cluster, of course. It's taking care also of the security. Also can create a user, for example, automatically. And you can schedule the snapshot, so for the backups, the key store, for the encryption, can do the failures, and is supporting the persistent storage. So if you lose a container, you don't lose the content. That is very important if you have a very large installation. And then it is supporting also very complicated and advanced topologies. So it's not only to create a cluster of 1 node, 2 node, 3 node, but inside Elasticsearch, the nodes can have a lot of different roles. It can be master node, it can be ingestion node, it can be data hot, data warm, data cold. So the infrastructure can be very complicated, and the operator is supporting all this. How it works? I wanted to show you, but no, it's 12%. Now I'm scared that if I start the virtual machine, it will shut down again. So how it works is this. For example, to play with it, I installed Minikube on my laptop. It's Kubernetes on a laptop. And Minikube, and then you need to install also kubectl, okay, to operate with the Kubernetes cluster. So from command line. Will come also then graphical in the user interface, but later on. So Minikube creates a virtual machine. So I use the VirtualBox. So you see, is creating a Minikube virtual machine inside the VirtualBox, and then is creating a one node cluster inside the virtual machine. I already installed the operator. It is very, very, very easy. Okay, it is this. So to install the operator is this command. You see, you interact with the kubectl, apply, and download, and so on. And the operator is in alpha, so not put in production. And then to deploy a cluster is very easy. So this is a page from our documentation, okay, that is explaining how to do a quick start now of a cluster. There is only one thing that you must do, because Minikube is creating a virtual machine with 2 gig of RAM, but our operator is using 2 gigabytes per node. Okay, so if you wanted to install one node Elastic, then it's fine. But if you want to create a cluster with multiple nodes, then of course you need to increase the memory of the virtual machine. Remember this because I learned on my skin. Okay, I spent days to understand why it was not working. So, for example, if we wanted to create a one node cluster, is this. Okay. So if we do kubectl get pods, that is showing the resources. We take a while. My laptop is dying, so slowing down. We will see. So this is the way. Okay. Here you will see. So we create a resource. Of course, it's called Elasticsearch with the one node. Okay. In what we have seen in the configuration here was the version 7.1 node count, blah blah blah. Now it will be very slow because we have also slow connection. Here, what is doing is downloading the binaries directly from our website and then installing them. Okay. To switch and to start to scale the cluster, then it's very easy. So first of all, this is to start Elasticsearch. Then to do Kibana is the same approach. We need just to change the kind. Is the Kibana instead of Elasticsearch version 7.1 one node, and then this will start Kibana. Then, if you wanted to upgrade, you do exactly the same. You put instead of node count 1, just node count 3. The operator will understand that I have already a cluster called Elasticsearch with one node. You want to go to 3, and will apply all the intelligence needed to add additional node in the cluster. It's done everything automatically. Okay, so you don't need to do it. I don't do it because since I need to download the binaries, it will take around 10-15 minutes with the disconnection, so we don't have the time to do it. If you want, we can do together this afternoon, because the time is a little bit over. Then in 15 minutes there is a lunch. That is the most important activity of the day. So if you have any question.
I have a question. You mentioned that the metric bit and the file bit can run in the diagram within Kubernetes. They are running as daemon sets.
Correct.
These daemon sets are the ones taking the data from the containers and from the pods?
With the logs of the container. So they read the logs of the container.
So there is no need to run file bit, for example,
Inside the
as a
container.
sidecar per pod.
Correct. Because if you have a central point where you can look at all the logs, you can read all the logs of your container, then you don't need nothing else.
But if I want to catch the logs that the container is sending to the standard output, then I need to do it.
Yes, then I need to do. Or you can have specific logs inside your container of your application logs. Okay, then in that case, or you can access that logs. You can write in a volume that can be accessed from outside. Then you don't need to run 5-bit inside the container. Okay. Or if this is not possible, then you can add the 5-bit. But usually, for me, it's better to run from outside. So this way, you don't have to change your container. And the definition. Tell me.
Do you plan operator for apps also?
This is an open question. This is an open question because it depends where we want to go. So here is working. So the idea is to use Logstash only for very complex activity. But in the evolution, so the bits will evolve a lot. So the concept is that in theory must be able to write directly inside the Elasticsearch. So if you wanted to do some transformation, then there is the ingestion pipeline. So we are evolving the ingestion pipeline, so you can do that. Of course, Logstash can collect information from many other sources, not that are not only ours, but for example, you can do SQL query on a relational database, or to read the Kafka queue or something like that. And in that case, the question is, we run inside the Kubernetes or outside the Kubernetes? Because I don't know if it makes sense so to run inside the Kubernetes, okay? And so this is not clear yet. No? So if we want to put inside or outside, it's only a matter of in an enterprise architecture where will be Logstash, if it makes sense to be inside or outside. But it's not so difficult to add. This is why it's still alpha, no? Because we needed to understand better the usage in the real world. No? That's it. Okay? Have a good lunch.